All right, so these next few lessons really build on the ones before. So you really have to understand prime factorization in order to be able to do greatest common factor. You really have to know what factors are. So the greatest common factor, or we might call GCF, is like the biggest number that is a factor of two or more numbers, right? So let's kind of put that definition into practice by doing a simple problem, right? So find the GCF, find the greatest common factor of these two numbers, of 12 and of 20. So one method, and I'm going to, spoiler alert, I do not like this method, right? One method is just to simply list all the factors of each number, and then if we're looking for the greatest, just circle the greatest. So for 12, right, the factors are 1, 2, 3, 4, 6, and 12. For 20, the factors are 1, 2, 4, 5, 10, and 20. You may or may not have known that, but that's what they are. And then, of course, we're looking for the biggest number that's in both lists, and the biggest number that I see that's in both lists is 4. So the GCF must be 4. Now, that's true, right? But maybe we didn't know all the factors of 12, or maybe we didn't know all the factors of 20, or maybe your teacher gave you numbers that were not as friendly as 12 and 20, right? So I really don't like method one. I think there is a safer way to do this. Okay, so I think the best method is the prime factorization method. Now this one might take a little longer. It's certainly going to take a little longer to explain, but I think at the end of the day, once you get better with factorization, you'll be able to do this, and you'll be able to do it when the numbers aren't as friendly as 12 and 20. So step one, we'll kind of put that off to the side, would be to do the prime factorization, right, for all, or if there's only two, both numbers. Okay, so let's do that, and maybe we know it, maybe we can do it in our head, maybe we can't, but if we can't, we have our factor tree, right? 4 times 3, 2 times 2. We circle our bottom branches, and there it is for 12. For 20, we're doing something similar. 4 times 5. 5's prime, 4 is 2 times 2. Again, if you need to, circle the bottom branches. And now we've got our prime factorization, and we're going to write them out. So for 12, we would do 2 times 2 times 3. Sorry, my pen is not working here. And for 20, we would do 2 times 2 times 5. So that's step one. Step two is to circle the factors that you see on both lists. So I might say circle the common factors, okay? So here I see a 2 on both lists, and here I see another 2 on both lists, and the 3 and the 5 are different, so it's just the 2's. Well, my third step is that the GCF is the product, right, of everything that you've circled. Be careful, circles only count once. So it's the product of the common factors, right? So the GCF in this case is, well, we take this one and we take this one. So that's 2 times 2, which is 4, okay? That will work every time, and it will work on numbers that aren't as friendly. Let's do another one, this time with some variables. Okay, so let's say we had to find the GCF of 16x squared y and 30xy squared. These are just monomials. Don't let the variables frighten you. You may or may not know how to factor the numbers in your head. If you don't, right, take the factor tree, 4 times 4, and then each one of these is 2, 2, 2, 2, right? So for 16x squared y, that's going to be 2 times 2 times 2 times 2. For x squared, right, that's going to be x times x. And for y, that's just y. There's nothing to do there. Okay, so for the 30, right? So that's 2 times 15, that's 3 times 5, and it looks like that's 2 times 3 times 5. Quick check, 2 times 3 is 6, 6 times 5 is 30, right? Times x times y times y. So if you think about our 3 steps, right? Step 1 was to primely factor both. We have done that. Step 2 is to circle the common factors, right? So let's circle. I see that we have 2's. And I don't see any more 2's down here. I don't see any 3's or 5's up here. I do see that we have an x in the top and the bottom, and I see that we have a y in the top and the bottom, right? So I've done step 2, and then my step 3, right, my GCF equals the product of the common factors. So my, whoops. Sorry, I'm having all kinds of problems today. My GCF is my product, multiply, of the common factors. I see a 2, I see an x, and I see a y. So that is my GCF. What does that really mean? That is the greatest factor that is common to both 16x squared y and 30xy squared. Your book throws one more thing in this section, and it's a bit of a curveball. Let's take a look at it now. So the last little final curveball they throw in here is they talk about factoring expressions. And for that, they mean, well, what if there's like an addition or subtraction sign, right? So they would say, well, factor 2x plus 8. Okay, well, what does that even mean? Well, the first thing that we're going to do, right, step 1, right, would be to, find the GCF of the two terms. Okay, that's not so hard. In this case, the terms are 2x and 8. So if we did that, right, we'd primely factor 2x is 2 times x, and 8 is 2 times 2 times 2. See anything in common? Yeah, so my GCF must be 2. Okay, the next step is to, and this gets new, pull out the GCF. Okay, well, what do I mean by pull out? Well, what it means is you take a 2 out front and you put in parentheses what's left. Okay, so what goes here? Well, what times 2 equals that first term, 2x? Well, the answer is x. Plus, okay, what goes here? What times 2 equals 8? Well, the answer is 4. Now, how will you know if you've done this right? Okay, well, if you now go in reverse and you distribute, okay, look what you got. You get 2x plus 4 equals 2x plus 8. That's right back where we started. Okay, so factoring an expression is like doing the distributive property in reverse. We'll do some more of these in class. It's basically the same thing. We still found the GCF of 2x and 8, but then we kind of pulled it out, and that can be a little bit of a curveball. So that is greatest common factor.